Hello, and welcome to FODES, the Future of Design and Engineering Software podcast. My name is Rupinder Tara. On this show, we will have guests that will discuss tools and technology that engineers will find interesting and useful. Today I have Tassos Hadjicocolis and Stephanos Androutsellis-Theotokis. Tassos is CEO and co-founder of Phenometry, and Stephanos is the CTO and founder. I met Tassos at the Develop 3D conference in the UK earlier this year, and he told me of their software that uses their own modeler to create shapes, not just prismatic shapes, all the MCAD programs do that, but organic shapes. All MCAD programs don't do that. After years of kvetching about MCAD's difficulty with organic shapes and generative design's abuse of organic shapes, I just had to have a deeper look. So here are Tassos and Stephanos to give me a more detailed demo. Nice to meet you.
Nice to meet you too.
I've been following your work, Rupinder, for very many years now. And so I think I speak for the team when I say it's exciting for us to all be in a call together and to be discussing our work. And thank you for that.
Oh, you're welcome. Glad to do it. I'd like to recognize good technology and promote it.
So hopefully I was able to share my screen. This is Phi now running from inside Onshape. So we have two options. One is to run as an Onshape add-on, in which case it appears in an Onshape tab, as you see here. Or you can run it independently on its own in another browser window without and still be connected with Onshape if you want. So you can authenticate with Onshape and pull your documents and work into Phi. And once we skip this welcome window, which by the way also leads to, so if you click here, it points to various quick tutorials and videos that are helpful for getting started. But once we are out of that, you basically start your design either by selecting one of these basic shapes that we provide, or if you have already saved some other model within Onshape or on file, you can upload it. But now just for a quick intro, I will work with one of these objects and then I'll give you 2-3 other examples. So let's assume I select a cube. I can give it some dimensions. And I can also give a name to my new design. So I'll just call it just one, whatever. And so we load this cube here. And I'll very quickly walk you around the interface. So first of all, obviously you can rotate, zoom, pan, and all of the usual interactions you have in any CAD system. And one of the things that immediately strikes us a little unusual is that with Phi, you can select any element of your model. So for example, this vertex or this edge, and you can just pull it and deform it. And the surfaces follow the deformation of the edges and adapt accordingly in a natural way. So this is a very, very quick way to manipulate your objects and change their shapes. And of course, there's a lot more you can do, and I'll quickly give some examples. Then if we look at the bottom of the screen, it's mostly visualization tools. So for instance, I can hide my vertices or my edges, or I can hide either all of my faces or select a few and hide just those, so I can look inside my object. Then I can rotate down the X, Y, or Z axis, so I'm looking along an orthogonal direction. If I am too zoomed out, I can click this button here and bring everything back in the scene. I can also select any face, regardless of whether it's flat or very curved like this. And with this button here, I can rotate so I'm looking roughly down perpendicular to this face. Of course, it has if it's very curved, it will be an approximation, obviously.
Okay.
I showed you that you can freely rotate around any axis, but you can also lock your rotation. So it now happens only around a vertical axis or around a horizontal axis. And this is sometimes useful to inspect your object without losing track of where you are. Okay, I will not waste a lot of your time to go over everything, but just 2-3 more examples. You can select various edges, and when you hit this button here, you get a curvature comb, which interactively adapts. And by the way, let me interrupt for a moment to show you that in the settings menu, we have various options, among which to show tooltips. I had this off at the beginning. That was a mistake. So I'll turn on the tooltips. So now whenever I hover my mouse over any button, I get a quick explanation of what it does. And for the top buttons, which are the tools that you have for your design work, and I'll go over them in a moment, you get more than that. So for example, if I hover over this first button, I get a little video showing me how it works. And if I hit read more, I get a bigger window with a complete description of this functionality and how I can use it, shortcuts, etc. So we tried to put a lot of help within the application, very close to the user's actions. And back to the bottom row, okay, we have a grid where you can snap, and we can also work in a section view. So here we create this block around the model, and then you can push this in. And as you do that, it cuts through the model, so you can have a section view. And you can also hide the section planes and still do your design work within this section environment. Or I can turn it off, and then I'm back into normal working.
Okay, it's still, do you mind if I ask questions?
No, absolutely.
Okay. When you show a section view and you act on the section view, it's still affecting the whole model, correct?
Yes. The entire model is there. You just don't see all of it. Yeah.
Okay, got it.
Right. So exactly, things happen in the parts that you don't see. You will see it when you go back into Fusion.
All right.
Okay, on the left side, we have more control things like undo and redo. This button is a restart, so you start with a fresh new model. You can also bring in another part. So for example, with this load model into current one, I can select a cylinder, for instance. And now the cylinder was added actually exactly on my queue, but that's fine. I can select it and move it out of the way. So now I have two models in my scene, and I can actually even select these two faces, and I'll quickly show you a bridge between the two. So these two were naturally merged into one. We calculated some new faces to add there, and this is a new body, a new single body. This is the result of this merge.
Okay, but when you move the part, can you control it? Can you control the movement to have it only along one axis or the other?
Yes, of course. So to do that, I'll jump to this move tool here that I haven't had a chance to describe yet. So I can either select the entire body, or I can select a part of the body only. It's the same thing, or even just a single vertex. And if I hit this button, I get the move manipulator. There's a shortcut for it. So this allows me to move either along the X, Y, or Z. I'm sure you're familiar with many such tools, or rotate around there. And as you see, the rest of the model that is not being moved adapts. So it elongates, etc.
Perfect. Okay.
So this is the move tool. As I mentioned earlier, you can add vertices on your edges. So there's also a shortcut V. So anywhere I am, I hit V and I have a new vertex, or Shift V and I have a vertex in the middle of the edge. Or for example, I can select a face, and then if I hit V, the vertex will be added onto all of the edges around it. And there's many more variation of these. For example, if I can hit Shift many times, and every time there's one more vertex added, so then I split my edge into so many equal length parts. Anyway, so you get tools that when you are become familiar with, they make your work a little faster.
If I may interrupt, sorry, Stefane, because you covered the move tool because Rupinder asked for it, but I think an interesting aspect of the move tool, and it exists in some other tools too, is that you can actually be precise you can ask, let's say, for yeah, okay. So you can take, so you can ask for a rotation of certain degrees, or Stephanos can demonstrate some of these because there's much more than what you saw. And by the way, when I say Stephanos is in a bit of
instead of dragging, you can actually, can you type in a number?
Yeah.
Yes,
exactly.
Yes.
So if instead of dragging my axis, I click on it, I get a little box, and I can give it, I don't know, 0.2 centimeters. And so I get a movement by precisely this amount, and the same for rotations.
Very nice.
So I do 10 degrees. So you have more control over there. Let me just go back here on the left menu then, before I go to show you a few more of our tools. So I was mentioning that you can load another object in your scene and then do operations between them. This is the icon to save your model, so you can give it a new file name and save it within Onshape on the cloud, on the Onshape cloud, or even download it on file to keep it. And this here is a very interesting button that I will demonstrate in a moment, which directly, if I hit it, it sends the entire model that I am working on into Onshape. So what it does behind the scenes, it converts it into into a step format, converting our surfaces into NURBS surfaces with very high accuracy. And then it sends this over to the Onshape API. So it goes into my document in Onshape, and then Onshape takes over and it converts it into their standard format, which will be a part studio. And I will demonstrate this, but I'll do it in a moment with a little more interesting example, so I can show a couple of things.
One question: when you convert it to NURBS, you're going from n-sided patches to NURBS. Can you adjust the accuracy of the conversion, or is it just one setting?
So yeah, the accuracy is already pretty high. It is roughly 10 to the minus 6.
Oh, 10 to the minus 6. Okay. So yeah. as a percentage? As a ratio? Or as a
yeah, so if the whole thing is in a unit box, if the patch is in a unit box, so it is roughly of unit size, then the accuracy is 10 to the minus 6.
Okay. Got it. Very good.
Yeah.
So we have an internal parameter that we haven't exposed, which could determine the resolution of the NURBS export.
Okay.
We just haven't had the need to export it yet. So in theory, yes, it is adjustable.
Okay. Yeah. On the downside, it is not very few control points in the NURBS. It is.
I see.
It's not a small number of control points.
Okay.
We didn't have any requests for, if need be, we can, especially with some extra work that we're doing now, we can reduce the number of control points in the NURBS and establish a trade-off between the accuracy and the control points.
Got it. Okay. Yeah. Understood.
Okay. So I think what I'll do is I will switch to a little more interesting example, and I will use that to walk you through some more of the tools we have.
Okay. So, before you move on from that, sorry, I didn't catch you in time. I was going to ask what would it take, or maybe you're going to show this, but what would it take to blend those edges into smoother edges? Because that had.
Okay. Very good.
Okay.
So. Let me answer it in two ways. To blend the edges into smoother ones, you're probably thinking of an operation such as a filleting, for example.
In a very crude way, but I think you could probably do better than that with. So
what we have, and I will talk about this a little bit, is what we call a smoothen command.
Okay.
So smoothen has various ways in which you can use it. The general idea is that you give it one edge or a chain of edges, and you ask it to round or smoothen or fair all of them with some conditions. So let me give some examples. The most basic use would be I select these two edges. They have a sharp corner here. I hit smooth, Yeah, okay, I'll hide the tooltips again. They get in the way a little bit. So, and the result is that it gave this curvature, and so these two edges are now tangent. And of course, I can still go in and play with them, modify the shape, and the tangency is respected. And if I move the vertex around, the same happens.
So on that top edge now, if I wanted to make sure that it's the curvature matches
along
the first derivative or second derivative match. Do you know what I mean? Like if it's tangent curvature continuity, or it's second order curvature continuity, like you can do that in CATIA, actually match it quite well. Is there anything like that here, or is it just push and pull?
So with what I did now, I asked, I cannot specify if I want G1 or G2 continuity.
Right, okay.
It gives me a calculation where for example, if I show the curvature combs, they will match to a good extent, but Vasily, correct me if I'm wrong, I don't think that we guarantee G2 continuity or we allow control over that to the user.
Right? Yes, correct, and we are working on that. We're working on something we will call Phi 2.0, and we would go even further than that, allow G3 continuity and stuff like that.
Okay, all right. So right now, I don't know how important that is, but I was just if I was coming at this from CATIA, I'd want to know. But I think you're doing a really good job of this. So if you want to get continuity like G1 or G2, you'd have to use the combs. You don't have, you only use combs. Is that the only tool to match the curves, or is there also sometimes they use zebra striping to detect?
Yeah. So no, we don't have zebra stripes, but if you export the model to Onshape, we utilize Onshape's zebra stripes to examine.
Makes sense. Okay.
So
by the way, I have to say, I love the interface. The UI is so clean, and so it's still so functional. It's a really good blend of power and simplicity. I didn't have to use documentation once even. I didn't use it very much, but I found myself able to manipulate shapes. And that's very unusual for a CAD program.
Yeah, thank you. We try, simplicity was always a goal here.
Yeah. Thank you. That's great to hear, Rupinder, because you've used all the tools, so your opinion counts.
Yeah.
I wanted to very quickly mention something else here. You saw earlier that, for example, I deformed these two edges, made them a little more curved, and then I started moving this vertex around. And you see that how they have some, I could describe it as elasticity, and they kind of they gradually fall back into the simplest possible shape. So this is an intentional behavior of our edges.
I see.
We want them to respect the constraints. So, for example, be tangent where they have to be tangent, and of course interpolate vertices. But as we move them, they try. We with every move step we reduce the complexity and we remove curvature to try to get to the most fair shape. And if, of course, you wanted to maintain a more curved shape, you can always go in and add a vertex, and the vertex will lock the shape at its location.
Okay. Right.
And the edges would.
Stephanos, when you're adding a vertex, is it going to the center of the edge, or is it going near your cursor?
If I just hit V, it goes near the cursor. If I hit Shift V, it goes to the center.
Okay, nice.
I have these options.
Good trick.
Shift is one of the most commonly used in Phi keyboard modifiers that changes the behavior of many of the tools in ways that Stephanos will explain. And to come back into this freedom, in our first versions of Phi, we had allowed what turned out to be way too much freedom to the users, and the designers sometimes got confused because they could turn things inside out very quickly. And so they started telling us, no, you need to constrain me more. You know, if I want more detail, I'll find a way to do it, but more freedom rather. But you know, you need to constrain me more. So you know, some of those things are in place because of that. And still, there's a lot of ways to mess your shape up. I mean, you know, if you randomly just pull it, you will create self-intersecting surfaces that you know, that we are not preventing, and there's, you know, and so on.
Right. Who takes the credit for the UI here on your team?
That would be Stephanos. That would be Stephanos.
Oh, okay, very
Well,
good.
no, I mean, yeah, it evolved a lot. It gradually became what it is now.
Yeah,
through a lot of discussion and decisions.
It is one of the best I've seen, if not the best. So very good.
Thank you.
I moved to a different example just to demonstrate a couple more things. First of all, you see here an image. With Phi, you can load images into the scene, as many as you want, and then you can move them around, position them as you want, and these are also stored within your model. So next time you load it, they're all there. And this, you might recognize, is the handle of one of these Italian coffee mocha machines. It's a simple shape, but still it's a very, I don't know, at least I identified it as an interesting, very freeform shape that it's not exactly obvious how you would model it. I mean, it's kind of like a tube that has been twisted, and it's thin here and thicker there. So we thought this makes for an interesting case. So I just wanted to show you the steps that one could take, well, I would try, to design this thing with Phi. So I loaded the image, I saved you the time of loading it, and then I brought in this cylinder in a standard shape. So what I'm going to do is, using the move tool that we discussed earlier, I will rotate the cylinder and put it in place roughly at a starting position, and I will also scale it to try to trace a little bit this handle. And I know from having seen the actual machine that it's not really cylindrical, it's a little squashed. So again, I will do a squashing of the cylinder to make it more realistic. Now, obviously, this is not exactly correct, but...
So the squashing was done, sorry, Stefan, the squashing was done by scaling along a single axis rather than, am I right, Stefan? That's...
Yeah. So again, with the manipulator, you have your axes, you have your arcs for rotating, and these three balls are for scaling. So when I pull on one, it scales along that direction.
Yes.
I position my cylinder, and then I grab one face only, and I will scale this to get it roughly on the handle. And now, obviously, I can go in and deform my edges to capture the shape. Now, the interesting thing is that I can do what we call a pop-out. A pop-out is basically an extrusion, and it's one of the tools that we use most often. So I selected this bottom face, and there is this pop-out button here, but the shortcut is P. So what happened now is that this face was extruded to give me some new volume, and I can just pull it. It brings up the manipulator immediately for me. So I can pull it all the way down here to try to follow the shape of this model. And again, I can go in and do a little editing. And I can repeat this as many times as I want. So for instance, I will straighten this a little bit, and then I'll do one more pop out, and I'll bring it down here, and I will rotate it. And here I need to make this, make this a little bigger. And one last pop out, and there we are. So clearly this is not a very good shape, and it's not even very freeform. It's all straight lines and stuff, but it's very easy to take care of this. let me first move this roughly there. And now what I will do is I will grab these chains of edges and I will smoothen them, as we saw before. But there is again one option. If I hold the Shift key again pressed, it will smoothen my chain without moving my vertices. And that's what I want in this case, because the vertices are supposedly exactly where I want them to be on my model. So I want to just smoothen my edges. And in smoothening, sometimes the shape is not exactly what I want, but it's really easy to go in and move things around and recapture the and trace my shape. I'm not going to waste a lot of time on this, but I would like to demonstrate also that if I select, for example, this ring of faces, another tool that I have now is fixing. So with this button here, these turn gray, and it means that they are not allowed to change in any way. So I'm, let's say, protecting these faces from whatever I will do now. And for example, what I will do is I will select these 4 edges, and I will smoothen them to give the curvature that I want in the bottom side of this handle. And I do the same thing in the opposite sense, smoothen it again. So I have created a very nice rounded finish for my handle. I will go, here on the left is the menu to bring in images, and I can also hide my images. So this allows me to look at my model a little better. And I can, for example, pull this vertex out and change the curvature, or I can select these 4 faces and move them any way I want. So I have a lot of freedom to control the shape of my model. And let me bring in the image again. And in the same way, I can continue going up and trace the entire shape of the handle. You get the general idea.
The initial shape that you brought in, that the whole coffee thing, what was that? Was that a solid model or a surface model, or just a picture?
Just a picture. It's just an image.
Just a 2D picture. Okay, got it.
Actually,
Stefano, maybe you can show Rupinda how you can do you can bring in images for all the axes and change them and scale them.
Yeah, in this case, I only have this image. I will show it in the next model, but let me very crudely finish this design, because I would like to demonstrate how I can throw this into Onshape and then finish it off over there, which is an interesting...
All right, so you're basically using this image, a 2D image, as a tracing over it with a 3D shape, right? And
exactly.
Yeah, okay, good, nice. I've not seen this done like this. It's always a photograph or a picture on the side of on the table, and then you try and eyeball it on your screen, and it's this is nice.
But I think that designers, at least in concept design phase, they do this quite a lot. They have some idea of what they want to achieve, possibly an image, and they use it.
Or something they've sketched on with pencil and paper.
Right.
Yeah, it could be, yes. Okay, so now that I have this handle here, let's assume that it's good enough. It's not, but okay. For the sake of time, I hit this button, which sends it to Onshape. So I will call it, I don't know, Bialetti. It's the brand of this thing. And so now what happens is, first we send this over to our server. On our server, we convert this to step and NURBS. And from there, we send it over to Onshape. And as you see here, it says the model has now left Phi and it's traveling towards Onshape. And it should appear in a few moments as a new Onshape Part Studio. And there it is at the bottom left. You see this new tab.
Yes.
This is exactly what we designed. Okay, the scale is off, but that's fine. So this is our little handle. And I'll hide the Onshape planes. That's it. And this is a perfectly valid B-rep object, so I can go in and do filleting, for example, and anything else I want with it.
So this is a solid model. This is a parasolid.
Yeah. At this point, yes, because Onshape converted it to a.
Okay, and does it shows, it demos well, but do you have any cases where it doesn't convert properly? It's not watertight. It's not. There are issues.
I'll tell you, if I do something weird in Phi, because Phi doesn't put any guardrails. So if I wanted, I could, for example, take this edge here. I'll do something very stupid now and pull it all the way up so it intersects the model itself.
Okay.
So obviously, if I send this over to Onshape, it will complain. It might reject this face or something like that.
Okay.
But other than that, it's quite unusual that we build something in Phi and then we don't see it as it should be in Onshape.
Okay.
I think Parasolid is doing a very good job at converting and bringing it into Onshape.
Okay.
Well, our description, it's a simple, because everything is watertight in Phi. Even taking into account, let's say, the self-intersecting surfaces, although you create a non-manifold. If the shape is, it's not doing something crazy, then it's a straightforward thing to just send the NURBS patches all as one, and to create the step file, and then for the step translator of Parasolid to bring it in and turn it into a B-rep. So yeah,
I understand the connection to Onshape because you're both cloud-based, but since it's making a parasolid model, why not develop or is that the next step, a SolidWorks?
Yeah, absolutely. I mean, you could do anything. In fact, it's not even creating a parasolid model at this stage, although we experimented with that. It's creating a step file. So it's something that's even more widely, can be even more widely used. And you can save it, by the way, you can save it as a step file if you want. And so bring it into SolidWorks manually, but you're absolutely right. We could integrate with other CAD software, definitely.
Okay.
And I just wanted to take this one little step further. Just now I'm mostly talking about not so much the capabilities of Phi, but what we consider to be the design process, the recommended design process, let's say. So what I'm doing here is I brought in this new cylinder and I'm placing it roughly over there. And I will pull out this vertex of it. And I will also smoothen everything like that. So I have this, let's say, bullet shape. And I'm going to select it and make a copy of it. You can have, I rotated it instead of moving it. So I select it, Control-C, and I grabbed the wrong thing. And I'll move it over there. So it's roughly symmetric. By the way, we also have mirror and symmetry commands. I can talk about it. And so what I'm attempting to do here is the following. If I hide all of my objects and we look at the image only, you will see here at this area, there is it's like part of the body is missing. There's a
cavity.
Exactly, a cavity. So the way I'm suggesting you could go about this is create these two shapes, which at least in my mind represent the negative space of the cavity, and then send over this entire thing to Onshape. And by the way, what you will see now in this tab is that we have what we call live update. So any change you make into Phi, it will automatically update within Onshape. So this is going to take a few more moments. Of course, I think I will lose my nice fillet here because with this addition.
So Stephanos, you in the first time you did this, you actually did a conversion and sent it over into step and then into Onshape. Are you saying now, everything you do to the Phi model is automatically stepped to Onshape, or do you have to still push a button?
I had to push a button. The send to exactly. I got the question. No, I pushed a button. There's no constant. It's not constantly updating. No.
Okay.
No, that would be. I mean, that's possible, but I think it would be very slow and possibly not exactly what you want.
Yeah,
but,
it would be checking all the time, and it would be
yeah. I think it would make things very slow.
Right.
If it were fast, it would be a very nice feature.
Can you do it from the other end? You're doing it from Phi to Onshape. Is there anything you can say in Onshape once you're there? Say, update this model with the Phi?
No. It's a one-way thing.
One way, okay.
Yeah, because we have lost there's no association between the two parts.
Okay.
I mean, the two worlds.
Yeah. Okay.
So there's no way to tell Onshape to tell us, and also many of the operations that you would do in Onshape, we do not support in a symmetric way, let's say. So if you were to do something here, we wouldn't probably know how to do it in our world.
I see. Okay.
So I see
it has
this
to do with the underlying representations too, because it's the parasolid model and the Phi model are entirely different in structure, in concept, they're totally different. So you cannot have a one-to-one correspondence.
Right. Can you do this? Can you take a Onshape model that's not okay? Let's say now you've taken this, you put it onto Onshape. Now you make a lot of changes. You do your Boolean operation just like you did there. Now can you send that to Phi? To Phi? I'm sorry, I'm just saying Phi or Phi.
Either.
Yeah, and then can it convert back to an n-sided patch then, so you could do something, or no?
Okay, the answer is the honest answer is that in most cases, no.
Okay.
So I can give you an example. I'm back into Phi now.
Okay.
I will actually start a new model. Let's forget about this one.
Okay.
Just load something, a cube.
Couldn't you easily enough create a step file from this, and then can Phi read the step file or not?
No, we cannot read. What we attempt to do is to read Onshape models. So I'll give you an example.
Okay.
This first button is to bring things in from Onshape. So here are the models that I have in my current document, and you see this is the handle that I just demonstrated, I just created.
Yes. Right.
And I can select the entire Part Studio and I can import it.
Okay.
And it will import it.
Okay.
But by default, it will not attempt to convert it. Let me hide this cube. So here it is. But this is not editable now. This is just a reference object that I can use to attach things to it, etc.
Got it. Understood.
I will try this once again, just to demonstrate this. I select the same part, and we have this flag here, which says attempt to convert it.
Okay.
So we will try to recreate in Phi all of these surfaces. And the thing is that in this process, it is not guaranteed to work. So in this case, actually, it did let's say, an honest effort.
Okay.
So what you see here is the model that we brought in from Onshape. But you see that it rejected some faces.
I see.
The reason it rejected them, I think it's mostly due to the fillets.
Oh, okay.
This is a big discussion, and there are some requirements that our faces have that Onshape doesn't have. For instance, you cannot have a face that has disconnected loops of edges around it. So a cylinder like a can of Coke, for example, The cylindrical face has a loop at the top and one at the top at the bottom, and the two do not touch, they're not connected. So we don't like that. So if you were to import that, we will request that you slice it in the middle vertically to create two faces that are proper for us.
I see.
And there's a bunch of other constraints, like how many corners you have which are not sharp and things like that.
Yeah.
And the result is that, unfortunately, in many cases, we reject part of the faces. Now, this was let's say, a decent effort.
Yeah, yeah.
But I think a designer would not be very happy with this. They would expect, I mean, either tell me that it works and it always works, or tell me to forget about it. This halfway.
I'd say it's 90% there, but I think this would be, in my mind, in my opinion, this would be important because you do such a good job of getting it over to Onshape in the first place. But I think that as a product designer, I'm going to want to go back to Phi because I'm going to discover things that I can't do in Onshape, and I'm going to need to go back to Phi to do that, right? So I know I'm asking for a lot because the programming here is probably intense, but to be able to do that, I think is very important to the process, to be there back and forth, to allow that to happen. I think to me that'd be critical. Instead of a one-shot deal, you have like the ability to go back and forth.
Yeah.
It would be, how can I put it, a more useful companion to Onshape.
Yes.
Yeah, just my opinion.
For sure. And we get that. It's one of the first questions we always get. Can I have this thing I've done in Onshape? Can I bring it into Phi and then play with it?
Yeah.
Absolutely, you're correct.
Yeah.
As a different way to look at it might be if you consider, for example, in I think Rhino or Fusion 360, where you have the ability to create some surfaces with sub-D tools or something like that. Then you can build on those by doing CAD operations like Booleans and etc. And so it's, in my view at least, it's like you're working in two layers. There's the fundamental layer where you do the surface work, and then this locks, and you go into the layer where you do the Boolean operations, etc. And in that sense, I think Phi gives you that possibility. So if you go back to Phi and change something, it reflects in the Onshape world. But I agree that it would be fantastic if we could just go the other way also. Currently, we don't have that yet.
Yeah.
When you get your next round of funding, you're going to.
Yes, it's one of the things. You could always find cases that will break down, but that doesn't matter because if you cover the vast majority of the cases, that's great. So you could write heuristics to deal with some of the problems we described, like the fact that the difference in the underlying infrastructures means that even if you bring in all the edges correctly, which is easy to do actually, to bring the edges correctly, that we do perfectly, it doesn't mean that the surface patch delineated by the same edges will look the same in Phi and in Onshape, because there's a different way of calculating it. And so there's all these little things that are, let's say, a bit of a minefield, but definitely there could be a lot of work done to make this a much better process. For now, because it's not there yet, we do not recommend it as a workflow, and instead we provide an alternative, which is what Stephanos, one of them is what Stephanos demonstrated. And another thing that I think Stephanos was going to show, but got sidetracked, was that you may not be able to bring in the whole model, but this reference model is not just to view. You can actually snap Phi edges onto or vertices onto edges of the Onshape model that you brought in, or the outside model that you brought in.
Okay.
And you can also ask for specific faces to be turned into surfaces to be turned into Phi surfaces, which is also very useful because in theory you have, let's say, your more mechanical design model done in Onshape, and then you want to add some freeform features, like you have a vacuum cleaner and you want to add a beautiful curvy handle. And then you can very easily like that define the interface and attach it on Phi, so you have precision there and you have an exact interface, and then work with the rest in Phi. So that's another very good workflow.
So the points in the 3D model from Onshape, let me see if I got this right. You can access the points and edges on that for making your surfaces, right? So it's not just a dumb backdrop. It's actually
exactly.
Yeah,
Stefano, would you care to maybe demonstrate?
Yeah, I can give you an example. I had another model.
Like in the photograph or the illustration, I couldn't snap to anything. I had to eyeball
no,
it.
on the photograph, no.
Yeah, but on the model that's coming in from Onshape, I have
the model is
access
coming in as geometry. So
okay, all right, good.
Yeah, so I have this model of an anvil. So this is from Onshape. And for example, I have this cube here, and I can place it roughly there, and I can select this face here and ask to snap it onto this face here. So I got a perfect match between the two faces. Or, for instance, I can put it here and I can ask this edge to snap onto this curved edge. So this is a good starting point. It helps.
Yeah, no, it helps a great deal. I can see how you make your initial shape when you put blocky, and then put the final, make use it as a starting point. Then it's a very useful starting point for making it more ergonomic or organic or smooth.
Yeah, so basically we use this as an example of how you can finish up this design within Phi. I mean, I hope I can. I don't remember exactly the shape, but to create the front part of the anvil, which is this curved nose. So let me snap this face again over there.
Ah, nice.
And then I guess I would probably now I'm just slicing this in half with these edges, and then I can get rid of that part and this part and these four edges. I'm not really sure what I'm doing here, but maybe something like that. Actually, I don't think I need this either. Just make this rounded.
Oh, I see. Yes, I see.
Maybe something like that. I don't know. And probably you don't want these edges either. So anyway.
Yeah, very nice.
Carving your shapes.
Nicely. I like the way it's shaping up. I tried doing that in Onshape or SolidWorks.
Yeah, it's not that easy, I think.
Yeah.
And then I can send this over to how should I call this? The tip of the anvil? I don't know. I send this over to Onshape.
Yeah.
And while this,
so you can do quite a bit of back and forth then, if you want to.
Yeah, in a sense, yes.
Yeah.
So now I can have an assembly, and I bring in my anvil and also the thing I designed just now. And there you have it. So, I mean, this took like what, 2 or 3 minutes. It's not a good shape, but I think if you wanted to do this in Onshape, it might be a considerably bigger task. Yeah, so we have some help there.
Oh, very good, very good.
I was going to show you one more example here. First, just to show that the user interface has also the option to give you to add colors and things like that, which is not really crucial, but anyway, it's something to be able to do that. And also we have this shadow plane, which we found to be useful if you want to get a better 3D understanding of your shapes. And so these are 3 carafes, and the designs differ mostly in the shapes around the bottom parts. And also, in some cases, you have sharp transitions, and in other, they're rounded. So I wanted to take this opportunity to show, for example, again, if I take these 2 edges and I hit my smoothen button, I get this rounding here. But more than that, I can go into, let me hide the shadow plane. I can select some of my edges, or even all of them, and go into this menu here, which is the tangent manipulation menu. So now you see these blue lines represent the tangents.
Yeah.
And now the same manipulator can be used to change them. So now I'm only changing the direction of the tangent over here.
I see.
And so you have a much more control over the shapes of your models, and I can do the same anywhere.
Stephanos, would you, at this point, would you turn on your combs to see if you've got
sure.
that right? Yeah.
Sure.
You can also fix tangents and do a whole lot of other things. You may have noticed, Rupinder, when these menus have a lot of, when Stephanos presses the smooth menu, for example, there's lots of little icons that come up. So there's lots of things, there's lots of things hiding there. So if you have a bit more time, we could go through some of them if you want. But...
Okay, so you can play with it to your heart's content. You can keep working at it until it's appealing and smooth and perfect.
And you can change the size and the density of the combs.
Stephanos make them a little bigger because I think.
Oh, nice. Okay.
Yeah, so you can see them better.
Yeah. What was your inspiration for this? Was it like Alias, or was it Rhino, or who?
We tried to get good ideas from wherever we could. Wherever something seemed functional, but that also we improvised a lot and had lots of very kind designers get frustrated with our experimentation and give us feedback and say, why don't you do this like that, and why don't you do it like that, until we found something better.
Yeah,
it requires a lot of iterations.
Yeah.
Like everything, I guess.
Right.
Actually, this is what I had prepared to give you a quick overview. I don't know if it helps a lot, and of course we can have as many sessions, or just drop us an email with questions or anything you want.
Now I would like to now play with it myself and see if I can do any damage.
I'm sure it's. I mean, there's a lot of work in Phi, but it's also work in progress, and we can. Stefan, if you have some more time, and Rupinder, of course, if you have some more time, would you care to just, in broad strokes, describe some of the other tools that we haven't touched on, that are on the top row?
Yes, sure.
The ones on the left are less interesting right now. I mean, there's something to display triangulated faces rather than full faces, or to bring in STL, or bring in more images in XYZ planes and so on. But the main tools, at least, so Rupinder can have a good go.
Okay, yes, please.
Yeah, so let me start. Okay, to add this is to add vertices, which I demonstrated. The shortcut is V, and it puts a vertex on the edge. And this is to add an edge once you have selected 2 vertices, or if you don't have any vertices selected and you hit this button, you go into this drawing mode where the entire model turns this color, what is it, cyan, I don't know. And then you move your mouse over one or more faces like that. And once you lift the mouse, it will draw edges along the path that you carved. So it's a way to add some edges a little more interactively, let's say.
Okay. So when you're drawing on the screen, it's in 3D, it's floating in 3D space, but then it maps onto the surface?
Exactly. Yes.
Using your perpendicular to the screen.
Yes.
Okay.
Yes.
Got it. Okay.
An orthographic camera, so it goes perpendicular, and it traces. It hits the object, and then it tries to add an edge following the path.
I see. Nice.
The next one is the split. So I can select one or more faces, and with a split, it just splits them in half, in 4 parts, actually, in 2 halves. Mm-hmm. So another, just a fast way to add edges.
Right.
And the carve command is very similar to the drawing edge, but it goes through the model. So if it hits a face, it will continue, and it can hit the rear face as well. So let me bring in a cube just to demonstrate this. Okay, it's a big cube, but it's okay. So carve, I'm going over here like this. I lift the mouse, which means I've completed my design. And so it sliced this entire corner. Okay. And this brings me to the next, which is dissolve. So this is an interesting discussion. As you saw, I removed this corner of the body using dissolve.
Yeah.
So what's the deal with this? In Phi, you can select an edge and hit delete and get rid of it, or the same with vertices, like I did before. But you cannot select a face and remove it, because that would leave the object in a not closed boundary representation state. So instead, you have 2 options. One option is right under delete, you have this button, which means make invisible. So the face is gone for all practical purposes, but in reality, internally, it's still there. You don't know it, but we still keep track of this face, even though it's invisible, let's say, in transparent. And I can select any edge around it, and again, with the same button, I'm bringing it back. And in fact, in bringing it back, we also do some clever stuff. We split it in triangles. Anyway, it's another discussion. The other thing you can do is what I mentioned, the dissolve, which is, the operation is this. You have a body which can have many faces. You select some of these faces and you hit dissolve. So what we do is we get rid of all of these faces, we remove them. So imagine before I selected these 3 faces, so we remove them. But in order not to leave you with a hole in your body, we substitute them with one single face to take the place of those. So we call it dissolve because it's like the 3 faces dissolved and only one took its place. And
but dissolve seems to be a very powerful, do everything sort of command.
It is a good, yes, I think it is. And it also has this other characteristics. So now I did 2 pop-outs just to create this ring of faces around here.
Okay.
So if I select this entire ring and I hit dissolve, it gets rid of all these faces, but then it's left with 2 parts of the body and nothing in between. So it decided that it should split it in 2 bodies and cover each side with a new face. So it's like it's responsible for giving you closed B-rep representations after you remove the faces, no matter.
That's also the dissolve command?
Yeah, same command.
Same command. Did you invent that? Is that a Phi invention, or is that does that exist in other?
Probably. I think I haven't seen it anywhere. Yeah.
You might want to get a patent on that.
I don't know. I guess.
Yeah. They've made software patents, understandably so. I think it was a good thing that they did so much more difficult now, because, as you know, Rupinder, for a long time they granted ridiculous software patents. For pressing a button or doing a click at the here or there, and
But you don't do that so much anymore? The patent office is not.
No, they don't do that anymore, and I think it's a good thing, because there's pretty ridiculous patents out there. Having said that, this might be patentable. I don't know.
It's a tool. I think it's a tool, and I think I would. I don't know every other Surface program that intimately, but I've not seen it stuff like that. This something like dissolve, and that could be a highlight.
Right.
Patent. Yeah. Okay. All right.
Okay,
Please continue.
delete, we mentioned fixed dimension. Move is the move manipulator. Scale is very similar to the move. It allows you to scale the size of objects. Okay. Now, since I had brought this here,
with a lot of precision, you will find a lot of precise tools within these scale submenus and all those that you could add numbers, you could by different axes and so on. Hopefully the videos and the documentation might help, but as Stephanos said, we're always here to answer any questions you may have. If you get frustrated or if you can't find your way around, we'd be more than happy to do so. Okay.
All right. Very good. Good to know.
So what I was going to demonstrate before, I brought in, this is an STL file, 3D scan of a bone of some sort, I don't know what. So I loaded it, I mean, it was already loaded in the file, but you can load it, using the STL command. So you hit that, and if you have an STL file in your document, you can select it and bring it in. And I had placed a cylinder, well, this, no, not exactly, this shape of faces around it. And we have this tool here, which we call attach to STL. So this is not perfect, but I will quickly show it. So what you do is you select the faces that you want to, what it does, it takes the faces and it kind of tries to attach them onto the STL file as closely as it can. So you select the faces you want, in this case, everything, and then I hit this button here. So now I'm in this mode, and then there are 3 buttons to, this is all described in the tooltip, by the way. So I can do 3 things. The first, I have the keys 1, 2, and 3. Okay, the interface is a little stupid, but anyway. So when I hit 1, it starts calculating how it should move all of the vertices to go as close to the body as possible. Oh. When I hit 2, it does the same with all of the edge samples. So now the edges will deform to attach. And when I hit 3, it does a little smoothening of everything, because in some cases it can be very jagged and etc. So it gives you this result here, which is, if I move it out of the way, for example, it's an attempt to replicate the shape of the STL that you brought in.
Oh, nice.
And we think that it's a useful feature. Yeah. We haven't found exactly an application for it. And for that reason, we haven't tuned it exactly. So here, maybe you don't want to capture so much detail. You want a slightly smoother result. Yeah.
So it's a smoothing operation, and that's under place?
Yes, because in reality, it's not exactly smoothing. It's a copying operation.
Or fitting, tries to fit something on something else.
I've heard it called conformal mapping also in some places.
Okay.
Oh yeah, that's a familiar term. If you'd asked me what it was, I wouldn't be able to tell you, but now that you said it, it's familiar,
yeah. I recognize it.
Yeah.
So that's
very
nice. We discussed the pop out. You saw that extrude we did several times. And the bridge. The hole, to be honest, I use it very rarely, but the general idea is that you can select. I will do this.
Maybe turn one of them into a circle, so to demonstrate that too.
Yeah. Okay. So I have this circular face here, and I have this square face over there, and they ask for a hole. So Phi will create faces inside the model and edges to build a hole, to drill a hole between the two. And as you see, they don't need to have the same shape or even the same number of edges around them. It will find a way to cut through the body.
Oh, okay. Wow.
We've squared the circle.
Yeah, you have. You have. This is a lot of fun. I could waste the whole day playing with this. Yeah.
Then we have the flatten command, which simply so if I will pull this guy out, and so this face now is obviously not flat, or these two faces, and I can select them, and with flatten, it will basically flatten them. So they became completely flat. Now, the result can be a little random. So what you can do is you can say, I want to flatten these two faces so that the resulting new face will pass through, you can give it 3 vertices. So these 3 vertices, for example. So if I do it now, I got a new face with a slightly different shape, and these 3 vertices were respected, they didn't move, and so you guide the result in that way. And similarly, you can take one or more edges and make them linear, or you can take a face and make it a circle, like I did before. I showed you how you can copy an entire body. So Control-C is the shortcut because people are familiar with it. So you select the body, Control-C, you have a copy of it. We saw the tangent menu, we saw the smoothening, and I think that leaves us with mirror and symmetry. So let me quickly demonstrate these. There are 2 different things. So with mirror, you select a mirror plane, which can be one of the orthogonal planes, or it can be a plane on your object, or you can even select 3 points to define a plane, but let's make it simple now. And so it creates a mirror image of your body, and anything you do on one side is reflected on the opposite. So it's like a mirror. Yeah. The interesting thing is that we have this button underneath where I can select. Now I only have one body, but if I had many bodies, I could select one or more bodies. Just select one face of them. That's enough. And then with this button, it disassociates the 2. So now it's working to make the mirror side an independent object. And there it is. So at this point, they're not related anymore. I can take this and move it out of the way and shrink it or do whatever I want. So basically, it's the facility is that you take a body, you make a mirror image, and then if you want, it becomes a new independent body for you.
Okay.
And the difference between a mirror and the symmetry command is that, okay, wait, let me start with a slightly simpler shape here. Because I don't know, a cube will do, I guess. So, yeah, so I have this cube and I go into symmetry mode. And now I can decide what the symmetry will apply to. So I can say I want these 2 edges to be symmetric with these 2 edges, and I don't even need to specify the order, it will figure it out. And I'm sorry, first I had to decide what plane I will use for the symmetry. Okay, so this is my symmetry plane. Then I will say, okay, for example, these 2 edges and these 2 edges will participate in the symmetry. And so you see the color change. They're green on one side and purple on the other. So now anything I do on one of these edges is reflected on the other side. And there's no guide. I can work on either. Right. But all of the other edges of my body, the ones that I didn't add to the symmetry set, they are free edges just like before. And then I can go in and select more edges, or in fact, I can select the entire face and add this also to my symmetry set. So I grow my symmetry set as I go along. And now these are also forced to be symmetric. So it's a very flexible tool where you can have a shape, but you only want one little part of it to be symmetric with something, and the rest you don't care about. And so this is a more flexible form of mirror symmetry tool. And we thought this would be useful, and I think it is. The problem is that it confuses people often because they see mirror and symmetry. Why do we have 2? And what's the difference? And I don't get it. And why can't you just have 1? So always with the users, you have to be, patient and assume that they're not very willing to put mental effort. They want everything to be super easy and obvious and fast, I think, sometimes.
Yeah, no, keep at it. I think it's a matter of education, I think, because he does so many things that they're not used to. I think they're going to have, so many CAD tools don't even have a symmetry function. Very, very well done, Stephanos. It's all live. Nothing was there's no canned, what we say, canned demos. It works smoothly. There was no, it's important. I always say it's important to note what you don't see. I didn't see any glitches. I didn't see any crashes. I didn't see any slowdowns. It's like, it seems to work.
I think the application is very robust. It won't. It will very, very rarely crash or even slow down. In all honesty, sometimes you can get some shapes that surprise you, and I did get some surprising shapes even in this demo a couple of moments. But I'm very good at hiding these. And
okay. So does it slow down as the model gets more complicated, as there's more peaks to it, as there are more patches?
I think only the number of elements. If you go really big, it can slow it down depending on your computer, because all of this runs on the client's computer. So it's all on your laptop, on my laptop. It's not the server does nothing. It only sits there and does the translation to NURBS and a couple of more small things.
Oh, I didn't realize that. Okay, all right. So
which is not what Onshape does. So Onshape does a lot of the calculation on the server side.
Yeah.
Ours was implemented very, very fast with algorithms that Tassos Androutsellis built, which are super clever, and so it's really fast. But if you load, I don't know, the tens of thousands of things, it can get slower.
We haven't done anything to optimize it for very big models, like, do load part of the model, and then depending on what you do, there's plenty of things that could be done. But right now it's not optimized, so definitely you'll see a slowdown if you load something big.
Okay.
And certainly for certain operations, even if the UI doesn't slow down, some operations will, because they're linear on the size of the model. Hopefully, maybe with some of them have some quadraticness has slipped in that we haven't found yet. But But as Stephanos said, and you will observe it yourself if you start working more on it, some of the shapes sometimes are surprising because of the way the surfaces are generated. Sometimes it may be unexpected. There may be a dip where you don't want it to be, and so you may have to go in and add another patch to try and fix that. Sometimes this can get a bit frustrating. Sometimes you don't get, let's say, the continuity you want, like you don't get G2 or G3, as Vasilis said, in certain parts, and it doesn't look great on the zebra stripes. And so, there are things like that, but, we're aware, we believe, of most of them, and we've done some great progress, especially in terms of not so much in terms of the workflow that we touched on before, because that, we haven't put the resources on it so much because we're sorely lacking in them. In the surfacing, we've done some great progress in what Vasilis called the 2.0 that hopefully is not too far away from an alpha version. And so we believe we address a lot of that and of what you will observe.
We're very fond of this 2.0, which doesn't exist yet, but it's going to exist soon. And so the idea with the 2.0 is that we will actually do a little bit of shape optimization, pure and honest and full strength shape optimization on top of what you see already. So basically what will happen is that there are some cases. I mean, we have a document with such examples which we're using for testing. Like Tassos said, there are cases where you don't get the optimal shape, and so what's going to happen with 2.0 is that when you drag, it will not be the optimal shape. It will be almost the optimal shape. But then when you leave the when you leave your mouse, it will become the optimal shape. And
oh, I see.
And then that will be that will resolve all these annoying cases that we see now. It will also simplify dramatically the workflow, and it will also be suitable for specific applications of which I am very fond of. For example, you would be able to build the hull of a ship where you want you want to be able to specify very few profiles, very few cross sections, and then you want the mathematics to figure out an optimal shape for you. And you don't want to do that by pushing and pulling, because even if you can do push and pull, it will take you forever to be at the optimal shape.
Yeah,
or it can be impossible to go to the optimal shape by push and pull. So you will be. So this optimization will come for free. Or another application is turbochargers, where
I can already see a lot of applications for that type of optimization, which I've been asking for and haven't been able to get, because conceptually it's easy. Mathematically, I think it's very difficult.
Yeah, mathematically, all the work we have done for the n-sided patches, then we need a similar amount of work for that.
Yeah. No, it's. I'm trying to find something in the office I can use to demonstrate it. I cannot, but I'll try to use if you can use your imagination. The idea of something going from one shape to another, you can do it with a mechanical spline. This mechanical spline is a thing from last century. It's a flexible, semi-flexible, but bendable object that you put on your drafting board, and it takes the shape of the least energy. It takes the least energy shape, right?
Yes.
So that mechanically is a very easy concept, and that concept can apply to many things, like fluid flow. The best path along between two orifices can take the path of least energy, least energy shape. If you could find a way to do that easily, I think it would have quite a few applications. So.
Yes, and so we're doing this on surfaces, and so this will ensure that you have G2, actually G3, between between connected phases, which we miss sometimes now. And it will ensure that those unexpected shapes do not happen. They happen only while you're dragging, but when you lift your finger from the mouse, those unexpected wrinkles, let's say, will disappear. And the thing will become completely smooth. And something additional, which is, I mean, it took us something like 1 year or so to realize. Sometimes, I mean, in the cases that Stephanos showed, the user is able to place the curves exactly where he wants. But in some situations, that may be impossible. For example, let's say you have a vertex and there is 5 curves emanating from it. And you want the entire surface at that vertex to be smooth. You cannot do this by controlling the individual curves. It's basically impossible. Especially if you say, oh no, I want my curve to be G3. Okay. I want my surface to be G3. It's very difficult. So all this will come for free. I mean, so you will so the user will be able to say, I want most of my curves to be, it's okay if you move them a little bit, but some of my curves, I want you to absolutely respect them. I want, you cannot move the curves, and the surfaces have to contain the curves.
Got it.
So this will be,
fix this and play with the rest.
Right. So this will be a small modification of the workflow, which will take out of the picture a lot of the nasty hurdles that we have right now. For example, okay, we didn't show this right now, but we have a limitation that you cannot have a face that has less than 3 corners.
Yeah.
Okay, so it's annoying.
Yeah.
So what you do is you have to split it. So if you want to have something very round, you split it into more faces, and then you have to control the more faces. But then with the new workflow, that will not be a problem, because you will say, yeah, okay, I added edges here, but I don't have to worry about them because the mathematics will take care of them.
I'm sorry, Rupinder, we get carried away. You can tell our DNA is mostly it's mostly engineering and not marketing, because we keep talking about the excitement of the things we're creating, and that's not a comment on, it's not shooting down the existing version of Phi, which we're all really looking forward to your trying and giving us your opinion. But it's all the excitement of working on new stuff, and having an attentive audience like you and knowledgeable it brings it all out.
For 20 years now, they've been saying CAD or modeling is a mature product and can improve. And so this is actually refreshing to see the ways that it can improve, the way that CAD, computer-aided design, could actually be computer-aided and not just documentation, right? So it needs to. We're not done here. We've got, all of us in the industry have got work to do. It can be better than it is, and it can be more of an assistant to designers. All right, very good. Nice meeting you, gentlemen. Thank you so much. Thank you for your time.
Please don't hesitate to reach out for anything.
Will do. Okay, thank you.
Have a great day. Bye-bye.
Thank you. Bye-bye.
Thank you for listening to FODES, the Future of Design and Engineering Software Show, brought to you by Eng Technica. I hope you have learned of a new application or technology that will help you with your job. If you have an application you think would be of interest to other engineers, please let me know by emailing me at rupinder@engtechnica.com or message me on LinkedIn.